Hi GOH, this is Unit 5, Lesson 7, and today we're going to talk about the distance formula. The distance formula actually comes from the Pythagorean theorem. So we're going to do a problem just like we ended with yesterday, where I have line segment AB. A is 2, 3, and B is 14, 12. It's already plotted on there. And I want to find the distance between points A and B. And as I said yesterday, I can't just count the length of the line because it's not a horizontal or vertical line. So what I am going to do is I'm going to create a right triangle. So I'm going to draw a horizontal line. All right, so A is at 2, 3, and B is at 14, 12. So you don't have to count them. I'll tell you what they are. And then I'm going to draw a vertical line. Okay, and I have now created a right triangle. And this point down here is 14, 3. All right, so basically I want to find the length of that vertical line and that horizontal line that I just created. So I can count the length. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this has a length of 12. Let me write that down. And the vertical line, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, where did I get that from? I looked at my x's and I subtracted them, and that gave me the length of that horizontal line. 14 minus 2 is 12. And then for the vertical line, I subtracted my y's. 12 minus 3 is 9. All right, but you can also just count it on the graph. But really, the end result is I basically have a right triangle where that horizontal line is 12 and that vertical line is 9. All right, I have that sketched on the graph, but I also just drew it here. And I'm trying to find the length of AB. So I'm going to use the Pythagorean theorem in order to do that. How could we calculate the lengths of the legs of the right triangle from the coordinates? Instead of counting them, because we're eventually going to do this not on a graph, and I already said this, we find the lengths of the legs by subtracting the x coordinates and the y coordinates. So we find the length of the legs by subtracting the x and y coordinates. And I already showed you up there, and I highlighted it for us. But basically, when I found the length of that horizontal line, I did 14 minus 2, so I subtracted the x's. And when I found the length of the vertical line, I did 12 minus 3, I subtracted the y coordinates. All right, so let's find the distance between, let's do the same thing right here. All right, and let's find the distance between the points 1, 5, and 3, 11 in simplest radical form by doing that, by drawing a right triangle. All right, so if I do this, I have 1, 5. So let's say that I have 1, 5 over here. Okay, and I have 3, 11 up here. So same thing that I just did before. To find the length of this line right here, I'm going to subtract my x's, 3 minus 1. And to find the length of my vertical line, I'm going to subtract my y's, 11 minus 5. So basically, I have 2 squared plus 6 squared equals c squared. 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. And to find c, I'm going to do the square root of 40. Now this one they wanted in simplest radical form, so I'm going to have to break that down. 4 times 10 is 40. 4 is written first because that's my perfect square. And the square root of 4 equals 2. So c equals 2 radical 10, or the distance between. So this right here, the distance between those points is 2 radical 10. Now, I don't want to have to go through this trouble all the time of drawing right triangles and using my Pythagorean theorem. So let me show you the distance formula, but first we're going to see where the distance formula comes from. So the same exact thing, I have 2 points one of the points is x1, y1, and one of the points is x2, y2, all right? And I want to find the length of this line. I want to find the distance between those 2 points. I'm finding my C. So again, let me just get a different color here. So I'm going to do x2 minus x1 to find the length of that horizontal line. And I'm going to do y2 minus y1 to find the length of that vertical line. So now using Pythagorean theorem, because this is a right triangle, just like I did up above with numbers, but now I'm doing with x1s, y1s, x2s, y2s. So I'm going to do x2 minus x1, and I'm going to square it. And I'm going to do y2 minus y1, and I'm going to square it. And then I'm going to do c squared. So this is just the Pythagorean theorem. A squared plus b squared equals c squared. A is x2 minus x1, and b is y2 minus y1. Now, in order to get c by itself, I have to take the square root of this whole thing. This is the Pythagorean theorem. Not the Pythagorean theorem. This is my distance formula. So using the Pythagorean theorem, I have now come up with my distance formula right there. And that's the formula I'm going to use in order to find the length between 2 points. And I don't have to draw it out on a graph, and I don't have to draw right triangles all the time. So distance formula, here it is again. It's the square root x2 minus x1 squared plus y2 minus y1 squared. That is my distance formula. That's how I find the distance between any 2 points. All right. Can I draw it on a graph and do the Pythagorean theorem? You absolutely can, but you don't need to. So let's try it out. x1, y1, x2, y2. So my distance is the square root x2 minus x1 squared plus y2 minus y1 squared. 15 minus 3 is 12. 7 minus 12 is negative 5. Now don't worry about any negatives because you're going to be squaring them. 12 squared is 144. Negative 5 squared is 25. And 144 plus 25 is 169. And the square root of 169 is 13. Okay, so if you know the formula, it's nice and easy. This is not on the reference table, but you guys are doing everything open notebook, so it shouldn't be an issue. Let's practice another one. x1, y1, x2, y2. You have your distance formula written right up there. Basically, you're taking the x's and subtracting them and squaring them, and taking the y's and you're subtracting them and squaring them. So x2, 5 minus x1, 5 minus negative 3, and that's squared, plus y2, which is 7, minus y1, which is 6. Now a minus negative is a plus positive, so this is 5 plus 3 squared, and 7 minus 1 is 6 squared. So 5 plus 3 is 8 squared plus 6 squared. 8 squared, you can use a calculator for this, is 64. 6 squared is 36. And 64 and 36 is 100. And the square root of 100 is 10. Okay, so each of these was a perfect square. Nice and easy to do. Let's do some that are not perfect squares, and I'm going to put it in simplest radical form. Sometimes they let us write it as a decimal, but then we're going to do some simplest radical form practice again. If it helps to label these x1, y1, x2, y2, please go ahead and do that. So it's x2 minus x1 squared plus y2 minus y1 squared. Negative 2 minus 4 is negative 6, but I'm squaring it. And 10 minus 1 is 9, but again, I'm squaring it. So you're never going to have a negative number because everything's squared. Negative 6 squared is 36. 9 squared is 81. And that gives me radical 117. Now you have to say what times what is 117, and one of the numbers is a perfect square. You might have to play around with the calculator to see what goes into it. But 9 times 13 is 117, and the square root of 9 equals 3. Okay, and for B, I'm just going to label these x1, y1, x2, y2. Again, it's 8 minus negative 2. I'm subtracting the y's and I'm squaring them. And then I'm subtracting the, that was the x's. And then I'm going to subtract the y's, 0 minus negative 5 squared. So this is 10 squared plus 5 squared. 10 squared is 100. 5 squared is 25. This one's a little bit easier to simplify, I think. Square root of 125, I have to simplify. So you're saying what times what is 125? 25 times 5 is 125. I write the 25 first because that's the one that's getting simplified. The square root of 25 is 5, and the other one stays radical 5. Okay, and now how am I going to use the distance formula? We're going to do what's called coordinate geometry proofs. Now, don't be afraid because I'm using the word proof. It's not a real proof. I want a given triangle ABC. It's already plotted there. A is negative 3, 8. B is negative 9, 0. And C is 5, 2. What would we would like to prove that ABC is isosceles. Now, isosceles means that two sides are congruent. Which two sides look like they have the same length? Well, to me, it looks like AB and AC might possibly be congruent. So I'm going to use my distance formula to find the length of AB, and then I'm going to use my distance formula to find the length of AC. And if they have the same length, then they are congruent, and it's an isosceles triangle. So again, this is called a coordinate geometry proof. We're using the coordinates in order to prove that two things are, in this case, congruent. So I'm doing the distance formula for AB. Negative 9 minus negative 3, I'm subtracting the x's, squared, plus 0 minus 8 squared, I'm subtracting the y's. This is negative 6 squared plus negative 8 squared. Negative 6 squared is positive 36, and negative 8 squared is positive 64. Oh, this is a nice easy one, which is square root of 100, 36 and 64, which equals 10. Now I'm going to find the square root, the distance of AC. So AC, I'm doing these two right here. Those are the points that I'm looking at. So the square root of AC is 5 minus negative 3 squared plus 2 minus 8 squared. 5 minus negative 3 is 8. 2 minus 8 is negative 6. But again, I'm squaring it. 8 squared is 64, and negative 6 squared is 36. And the square root of 100 is 10. So yes, this is it isosceles? It's isosceles. How do I know it's isosceles? Because AB is congruent to AC. So it's an isosceles triangle. And that is a coordinate geometry proof. All right, so we'll practice our distance formula.